Hi everyone, welcome to another video. Today I'm going to be showing you how to make this structure made out of lines that generates procedurally like that. And as you can see, each new line collides with the previous ones and it ends up filling up the space. We can also control the way in which the angle of each line is chosen so we can get different results. And we're gonna also see a way to add some color to it. And over here I also started experimenting around to try to make something similar to this but with quads instead of lines, and it's a little bit different. I had to do some weird tricks to get this working, but if you want, I'm gonna probably have that on Patreon as well if you want to check out how did I do that. And other than that, we can get started. So I'm gonna delete everything. So what we're gonna do is start off with a set of geometry that is a bunch of lines, and then within that first geometry we're gonna add a point with a random direction, and with that direction we can shoot a ray that collides with our previous lines and shoot the opposite ray that goes to the other side, and that gives us the information to create a new line. And then we're gonna put this into a feedback so that we create a new point, a new direction, and again shoot a ray, collide, get new points over here, and then we can just join it again, and so on and so forth. So there's many ways of generating points. I'm gonna use a sprinkle here. So let's start with a circle. I'm gonna, for now, put it to 4 divisions. I'm gonna rotate it 45 so it's square, and that can be our base geometry. It's a line strip, very important. I'm gonna put that into a null that is just called base, and I'm gonna copy and paste this so that we also get a surface in which we can use sprinkle. And here I'm gonna just need 1, and I want it to be always changing so we can animate this with uptime, so it's always a different position. I'm just using the same geometry because this point has to always be inside of the base geometry, because if we were to use a point that was outside, then the ray will be able to miss, and well, we don't want that, right? So it's important that this is the way you generate this, always it's within the bounds of whatever you started with. And now we can also get a noise, and use a noise to create the angle attribute. Angle, and from that angle we're gonna create the direction vector. I'm gonna put this amplitude at 0.5 and offset at 0.5, so this is now generating between 0 and 1, and that's important so we can quantize it later. Quantize the angle with floor, and well, I'm gonna bypass this for now, and we need to change the range from 0 to 1 into angles, so radians, which is 0 to 2 pi, to math of pi times 2. We multiply our angle, and now we have this angle, and we can create a vector that points in a direction. So let's create a new attribute that is called direction. It's 3D, and now with a math mix we can take the cosine of our angle, and that will go into the horizontal component of our direction, and the sine of the same angle gives us the vertical component 1. And here I need to set the angle units to radians because that's what the range we're operating in. And if I use here the vector viewer, you can see now we have a point with that is always changing, that is always pointing to a random direction as well. Or something, this angle, I'm also going to lower the period so it's more random. And here we go. Now we can perform our ray operation. So we can use ray and use that direction, but this ray needs this collision geometry that we can generate using our base. I'm gonna put it into a feedback because that's the feedback we're gonna use to keep building out the structure. And because this is a line strip, we can now use this extrude operator to give it thickness so that this ray can collide into it. Now these points are on the origin plane on Z. They have Z of 0. So I'm gonna put this, I'm gonna transform this a little so it's at least on top of it. So I'm gonna lower the distance here and just transform it to move it back a little bit, because just so the points are able to always hit it without any floating point errors or anything like that. You can put it back, and there you go. Now it's resting on that plane, and we can use the ray. And now this always gives us the point on our original geometry that intersects that array operation. And now let's just copy and paste, and on this one we can negate the ray, and if we merge them, now we have the 2 points of our new line. You can't see them because of its normal. I'm gonna turn here that normal off. There you go. And now we can connect them with connectivity, and we need line strips, and just turn off the dimension index, and there you go. That's our new line that we just need to merge into our feedback using a merge. And if I now drag this into our feedback, you can see it's already working perfectly. Nice. Now I want to have a little bit more control of when this is going to stop, because right now it's just going to keep on going forever and this is still climbing. So let's add a constant here just to have a maximum number of primitives, which right now I'm going to just put at 500. And let's call this data. And now I can here use a switch that is going to switch between this new merged geometry or our unmodified geometry. So I'm gonna reference this. I'm just gonna compare the current number of primitives that this feedback has against the maximum that we want. So I can get the current with the OP feedback 1. There's a function called nonprims, and this needs to be less than our prims minus 1. Oh, I mean more than, greater than. And you can see now this turns true whenever it gets big enough. I'm gonna also add here a keyboard int just to reset this. You can see it's 0. So we can connect this like this. This will be the end of our feedbacks, and drag it in, and now it's gonna grow, and you can see the primitives start counting up until it gets to our maximum, which is 500. There you go. And now let's render this. I'm gonna create another null here just to give me space. It's gonna be called geo. And if I use this new render simple, You can get something quick with a line material. I'm gonna use a math node with a line material, and then let's change it so it's white. There you go. Change the background. Now we see it. Now let's control the thickness of each line. We can use here. You can see that it uses this line width attribute. So let's create that attribute for our geometry. And one thing we can do is to make it so that the lines that were created earlier, which tend to be the longest, are thicker, and as they progressively get smaller and smaller, they become thinner. So let's get a math. With a math, we can get here from this is like attributes that are generated for us. There's the prim I, which is the index of each primitive from each point, and we can use that. Let's make that into an attribute that we can manipulate, and we can use that because the earliest ones are going to have a lower index, right? We can normalize our prim ID into line width. You can see it's very weird right now. We want the earliest ones to be thick and them to get thinner, and we can play around with the exponent and all sorts of things. So now let's start figuring out how to give it color. And for that, I'm gonna use a texture. I'm gonna sample from a texture. I'm gonna get the usual flower, and because our geometry right now is a square, I'm gonna just put it into a square, and that can be into a null. It's called color map. And now we need this geometry is between a negative value and a positive value, right? And for a lookup operation, you actually need it to be between 0 and 1. So we're gonna normalize the position and save it as a different attribute just for our lookup. So normalizing and change it into lookup position, like that. And we can use that in a lookup texture that's gonna use our lookup position, take this top and put the result into our color RGB. And you can see there's a little bit of flickering, and this happens whenever you're working with this line material and two or more lines have the same distance to the camera, the same C depth. You get this effect because the GPU doesn't know which to put in front, and because they are always trying to occupy the same space, you get this glitch, which is called Z fighting. And to fix that, we can just put the thinner, smaller lines behind and bring the bigger ones on front. We can change the positions again with another normalize, which uses our prim ID, and then it's gonna go into the Z component of P, and we want it the other way around. We want the smaller ones at the back, and you can see now we don't have that weird effect. And let's also, right now, as you can see, the way this color works is that each point in the line looks up this color from the texture, and it just interpolates along the line between those two colors. And we may also want to have it so that each line has a solid color. So what we can do is to take this lookup position attribute that we have from our points, and instead of having it defined on points, we can have it we can have it defined on primitives. So each primitive is going to have its own position, and we can just attribute convert from point to primitive. And let's get our lookup position. I'm going to call this like prim center, because when you convert an attribute from points into primitives, what happens is that it gets averaged out from all of the different points that are part of that primitive. So we're gonna get the center of each of these lines, and we can use this lookup texture to now use that in primitive. So let's change that to primitive and use prim center, and you can see now each line has a solid color, and you can see this border is very green because this first one is a single line strip, it's a single primitive, so the center of it is going to be right here, which is on this leaf. Okay, now we can play around with this quantization. I do it before changing it, doing the read range here, because now we can, this makes sense. If we change this to 1 divided by 4, that means there's only there's only 4 possible angles that you can choose from, and you get these orthogonal shapes, or 8, and you get something different, and you can play around with it. Also, this noise right now is a very low period, but if we increase it a lot and reset it, you can see that you get these big shapes. Now it's not so random, and I think it looks pretty cool. So that's pretty much it. Now also you can see this is a relatively small network. Before pops came out, I actually managed to make this same behavior using only tops, so no GLSL and nothing like that, just standard tops, and it was much more complicated than this, much more complicated. And if you're interested in that, you can hop over to Patreon and check it out. And also gonna have this quad version. So that's it. Hope you liked it.